All right, everybody, sorry about that. This is like 4 times doing this video. It's late at night. I keep making stupid mistakes, but we're on question number 7, the integral 2x over x plus 1 all squared dx. So this is a standard u substitution. It looks like the stuff we did before. The bottom is a second degree polynomial with a binomial in brackets raised to the power of 2. That is screaming at you for u substitution. Okay, so we are going to do u substitution on the denominator, and I'm going to get du is equal to dx. Well, I've checked off that to u, I've checked that to u, but I still have this x here. But looking at this, if I just move that 1 over, I get u minus 1 is equal to x. So this integral, I'll pull the 2 out, now becomes u minus 1 over u squared du. Again, single denominator, so we're going to want to split that up. U over u squared minus 1 over u squared du. And those can be separated into 2 different integrals. 2 times both of them, u over u squared is 1 over u du, so that's screaming at you for the natural log. And this we're going to rewrite as u to the negative 2 du. That's regular integration. So I guess it's 2 times all of that. First integral becomes natural log of u minus this one, you add 1, divide by 1. So I get u to the negative 1 divided by negative 1. Right? Sub back in what our u is. What was our u? X plus 1. So 2 natural log of x plus 1. That should be an absolute value of 2. This becomes plus 1 over x plus 1, and it's 1 over because this whole thing here simplifies to plus 1 over u. And then we tack on a plus c, put it all in brackets, and we're done. And you can multiply the 2 in if you want, but it makes no difference. All right, last question. Let's solve the integral y is equal to a definite, where we have bounds, integral from e to e squared of 1 over x natural log of x dx. So if you get a question like this, where there is a natural log in the integral, it is screaming at you to make that the u substitution, because you do not know how to integrate just a natural log function. Like if I said the integral of natural log x dx, you don't know how to integrate that. We will learn that later on. You have to use integration by parts, but right now you don't know how to do it. So we are going to sub out the u, or sorry, the natural log. So u is equal to the natural log of x. Well, what's the derivative of the natural log? It's 1 over x dx. Oh, look at that. So this integral now becomes integral 1 over x dx, right, plus that is du. And this was u. So I get 1 over u du. Now, it's a definite integral, so we can change our bounds here. And remember, this is x, right? These are x values. So when x is equal to e squared, u is equal to the natural log of e squared. Hopefully you remember that natural log is log base e of e squared. If those bases match, it is just 2. So u would be 2. So when x is equal to e, u is equal to the natural log of e, which is 1. These bounds become 1 and 2. And then we just evaluate the integral. 1 over u is the natural log of u, evaluated from 1 to 2, which is the natural log of 2 minus the natural log of 1. Hopefully you remember that natural log of 1 is 0, so my answer is just the natural log of 2. Okay, so what did we learn here? If you have a natural log in your integral, that is the u substitution you will make. If it is a bit of it looks like a normal integral, a denominator, or anything else raised to the power of 2 in binomial form. That's probably going to be your u substitution. You might have to solve for x, but we did that in the last chapter. And if it is a complex polynomial where it doesn't look like u substitution is going to work or anything, try long division. Always write your answer as q plus r over d. Or if you can rearrange the numerator or the denominator, is something that will break into two fractions and simplify quite nicely into a constant term and a log term, do that. Please practice these. They do get kind of tricky, and practice is the only way to get good at them. Page 334, numbers 15, 21, 23, and 25. All right, best of luck, people, and let me know if you have any questions.